Hello student, now in this video we will start the new chapter, that is a differential equation, and I will cover the two exercises from the textbook, that is a 6.1 and 6.2. I will explain all the examples in a very simple language. Now let us start the differential equation. The first of all, a differential equation. Differential equation, the equation which contains the derivative of a function, is called the differential equation. The following are differential equation. dy by dx is equals to cos x. Second, d2y by dx square plus k square y is equals to 0. d2w upon dx square minus x square dw upon dx plus w, that's equals to 0. These are the differential equation. Differential equation म्हणजे काय की ज्यामध्ये डिफरन्शियल डेरिव्हेटिव्हच्या टर्म्स असतात, they are called the differential equation. Now the next is order and the degree of the differential equation. The order of a differential equation is the highest order of the derivative appearing in the equation. The degree of the differential equation is the power of the highest order derivative present in it. ज्याची ऑर्डर जास्त असेल त्याचीच डिग्री आपण इथे कन्सिडर करणार आहोत. That is called the degree of the differential equation. To find the degree of the differential equation, we need to have a positive integer as the index of each derivative. प्रत्येक डेरिव्हेटिव्हचा इंडेक्स हा कसा असला पाहिजे, तर पॉझिटिव्ह इंटिजर असला पाहिजे. त्याच्यात रूट साइन, फ्रॅक्शन्स, निगेटिव्ह साइन्स नको असली पाहिजे. Then we can find out the degree and order and the degree of the differential equation. Now let us start the exercise 6.1. Determine the order and the degree of the differential of the following differential equation. The first is d2y upon dx square plus x into dy by dx plus y is equals to 2 sin x. Here the order of this differential equation is as 2 order, therefore order is 2. And what is the degree of this order 2? Its index is 1, and therefore its degree is 1. Second, in cubic root of 1 plus dy by dx bracket square is equals to d2y by dx square. Now to solve this equation, that is a take cube on both sides, then you will get 1 plus dy by dx bracket square is equals to d2y by dx square bracket cube. And here order is a 2 and the degree is a 3. Now the next third is dy by dx is equals to 2 sin x plus 3 upon dy by dx. Now we'll simplify here. That is a dy by dx numerator. Here if we simplify, that is a dy by dx, there is a divided, that is a dy by dx. It will come to the left hand side and will be the multiplied. Therefore dy by dx into dy by dx, that is equals to 2 sin x plus 3. प्रत्येकदा डिफरन्शियल इक्वेशन आपल्याला हे सॉल्व्ह करायचं असतं, म्हणजे एकाच रेषेत सर्व डिवाइड बाय dx च्या टर्म्स असल्या पाहिजे, त्या डिनोमिनेटरला नको असली पाहिजे, त्याच्या रेस्ट टू हा इंटिजर असला पाहिजे, पॉझिटिव्ह इंटिजर. Therefore dy by dx into dy by dx, that is the dy by dx bracket square, that's equals to 2 sin x plus 3. Now what is the order of this differential equation? कितव्यांदा डेरिव्हेटिव्ह काढला याचा? It's a first time. It's a differentiated first time, therefore the order is 1. And what's about its exponent? Its a degree is a 2. Therefore its a degree is a 2. Fourth one, d2y upon dx square plus dy by dx plus x, that's equals to square root of 1 plus d2y by dx square. Now to solve this, take the square on the both sides, because here the right hand side it's a square root, that's why we are making the squaring on both sides. Therefore d2y by dx square plus dy by dx plus x bracket square plus is equals to 1 plus d3y upon dx square. Now the highest order here, the highest order is here, that is a 3, order is a 3. And what about its exponent? Its a degree is 1. Therefore order is a 3 and the degree is 1. म्हणून डिफरन्शियल इक्वेशनची जर आपल्याला ऑर्डर फाइंड आउट करायची असेल तर हायेस्ट ऑर्डर कुठे ते इथे आहे, आणि मग त्याचा इंडेक्स आपण घेत असतो, त्याची डिग्री आपण इथे कन्सिडर करत असतो. नाउ द नेक्स्ट d2y by t square plus dy by dx bracket square plus 7x plus 5. Now in this case the order is 2, and what is this order? Its exponent, its degree is 1. Therefore order is 2 and the degree is 1. Now the problem number 6, that is a y triple dash, that is it's differentiated 3 times. Bracket square plus 3 into y, it's a differentiate 2 times y double dot plus x into y dot plus 5y, that's equals to 0. And here is the order is 2 and the degree is 3. Now the next question is, that is a d2y by dx square bracket square plus cos in bracket dy by dx, that's equals to 0. Here we define only the order and not the degree, because the question is not in the linear form, and therefore we degree is not defined. Now the next, that is a 1 plus dy by dx of bracket square and bracket raised to 3 by 2 is equals to 8 into d2y by dx square. Again, here is it's a exponent. Here is a 3 by 2. We do not there should be not any fraction. Therefore, squaring on both sides, and then you will get 1 plus dy by dx of bracket square is equals to bracket raised to 3 is equals to 8 into d2y by dx square whole square. And therefore you will get, that is the order is, here is the order is a 2 and the degree is also 2. Now the next is a d3y upon dx cube bracket complete in raised to 1 upon 2 into dy by dx and bracket raised to 1 upon 3, that's equals to 20. Now what is the LCM of this? The LCM of this is a 6. Therefore we will have, that is a take the 6th power on both sides, and then you will get d3y upon dx cube raised to 1 upon 2 raised to 6. And what will happen here? It's a order is a 3 and the exponent, that is a degree is a 3. Order is 3 and the degree is 3. That you have to solve this. Take the 6th power on the both sides. Now the next is x plus d2y by dx square plus in under root of 1 plus d2y by dx square and bracket square. Forget to write here 2 here. That is, here is a d2y by dx square. Now again the squaring on both sides, then you will get x plus d2y by dx square bracket square, that is equals to 1 plus d2y by dx square, here is a whole bracket square. Now what about the order is, here the order of the differential equation is 2 and the degree is 1. How it is? For that I had written here with the blue ink, square this bracket, that is x square plus 2x into d2y by dx square plus dy by dx bracket square, and that's equals to 1 plus d2y by dx square and bracket square. Now these two terms on both sides get cancelled, and hence the order is 2 and the degree is 1 here. Now the next topic is the formation of the differential equation. Formation of the differential equation, that is from the given information we can form the differential equation. Sometimes we need to eliminate the arbitrary constants from a given relation. It may be done by the differentiation. We will form the differential equation. That is a exercise 6.2. I will start direct. Obtain the differential equation by eliminating the arbitrary constant. Now the first equation is x cube plus y cube, that is equals to 4ax. Here the arbitrary constant is 1. Therefore, whatever that differential equation of this equation, its order is 1 because it's contain one arbitrary constant. Now differentiate this equation on both sides. This is the implicit type of the function, that is differentiate on both sides with respect to x. 3x square plus 2y square into dy by dx. 4x, the derivative of x is 1 and that is equals to 4a. This is the equation number 2. To eliminate a, what is our objective? To form the differential equation from any solution, our objective is that to eliminate this arbitrary constant a. Now we have differentiated here and we have the value of 4a. What is the value of 4a? That is a 3x square plus 3y square into dy by dx. Here is a dy by dx. To eliminate a from the equation 1 and 2, substitute the value of 4a from the equation 2. Substitute the value of 4a from the equation 2 in the equation number 1. Then you will get x cube plus y cube, that's equals to 3x square plus 2y square into dy by dx into x. Now simplify this. Then what you will get? X cube plus y cube, 3x square plus 3y square x into dy by dx. Therefore x cube plus y cube, that's equals to 3x cube plus 3x square 3xy square into dy by dx. Now from this equation, then you will get, that is a 2x cube minus y cube plus 3xy square into dy by dx, that's equals to 0. Here is this is the, if you simplify this, bring these two terms, that is the x cube and y cube to the right hand side, they will become minus, and you will get 2x cube minus y cube plus 3xy square into dy by dx, that is equals to 0. This is the differential equation. हे differential equation आहे. यामध्ये या सोल्युशन मध्ये बघा, हे जे दिलं होतं इक्वेशन आपल्याला, त्यामध्ये एकच आर्बिट्ररी कॉन्स्टंट आहे. Therefore the order of this differential equation is 1. Now the next is that is ax square plus by square, that's equals to 1. Now in this equation there are the two arbitrary constants, capital A and the capital B. Therefore whatever that differential equation, it must have the order 2. The given relation is ax square plus by square, that's equals to 1. This is the equation number 1. Differentiate equation 1 twice with respect to x we get, that is the derivative of x square. Derivative of x square is a 2x, that is a 2ax, plus derivative of y square is a 2y, that is a 2by, into derivative of y is a dy by dx, that's equals to 0. This function is implicit type function. Therefore we have multiplied here into dy by dx, that's equals to 0. Now cancel on both sides these 2, then you will get ax plus by into dy by dx, that's equals to 0. Now again differentiate this equation with respect to x, equation number 2. What's the derivative of x here? The derivative of x is 1. Therefore here is a plus b y into dy by dx. Now here is a y into dy by dx. Apply the product rule. Then you will get y into, what is the derivative of dy by dx? It's a d2y by dx square. Plus, what is the derivative of y? By using this product rule, इथे product rule आपण apply केला, b ला बाहेर ठेवलाय आणि y into dy by dx ला product rule apply केला. The derivative of y is the dy by dx, and here is the dy by dx, that is the dy by dx bracket square, that's equals to 0, and this is equation number 3. Now see this equation number 1, equation number 2, and equation number 3. Now we will solve these three equations, that is a equation 1, 2, and 3. Now we will solve this. What are the, this is the standard form, that is a arbitrary constant a, arbitrary constant b, equal to sign and 1. What is the coefficient of a is x square and coefficient of b is y square, and the constant is 1. Therefore we had written here x square, y square, and 1. What about the next? Here is it. The coefficient of a is x and coefficient of b is y into dy by dx, and the constant is 0. Therefore x, y into dy by dx, and here is a 0. What about the last, that is a coefficient of a is a 1, here is a 1. Coefficient of b is a y into d2y by dx square plus dy by dx is a bracket square, and here is a constant, that's equals to 0. Now simplify this. If you expand this, then you will get what terms are present here. जर इथे हा डिटर्मिनंट जर आपण सॉल्व केला, x square into y into dy by dx into 0, 0 into this term, that will become 0. What about the y square middle, that is a minus y square. The product of these two terms, that x into 0, 1 into 0, that will become 0. These two terms will be 0. What about the last term, that is a 1 in bracket x into in bracket y into d2y by dx square plus dy by dx bracket square minus 1 into y into dy by dx, and here is that terms, that is a 1 in bracket xy into d2y by dx square plus x into dy by dx bracket square minus y into dy by dx brackets dy by dx whole bracket complete, that's equals to 0. And therefore if we simplify this, and then you will get xy d2y by dx square plus x into dy by dx bracket square minus y into dy by dx, that's equals to 0. This is the required differential equation. Now the next problem is y is equals to a cos of log x plus b sin of log x. Now again this equation has a two arbitrary constant. Therefore whatever that the differential equation, it must have the order 2. It must have the order 2. Now see this here, y is equals to a cos of log x plus b sin of log x. Now differentiate this with respect to x. Therefore derivative of y is a dy by dx, derivative of cos of log x is a minus sin of log x into derivative of log x is 1 upon x. Now b sin log x, derivative of sin x is a cos of log x into derivative of log x is 1 upon x. Therefore you will get, that is a dy by dx is equals to minus a sin log x upon x plus b cos of log x upon x. And if you simplify this, then you will get x into dy by dx is equals to minus a sin log x plus b cos log x. Now differentiate again with respect to x. Now to differentiate this x into dy by dx, we must apply here the product rule. What is the product rule? That is y is equals to u into v. Therefore, u into dv by dx plus v into du by dx. In the same way, keep this x as it is, find out the derivative of dy by dx. It's a d2y by dx square plus derivative of x is 1 into dy by dx. Now again differentiate this term. What is the derivative of sine of log x? It's a cos of log x upon derivative of log x is 1 upon x. What is the derivative of cos of log x? It's a minus sine of log x upon x. And if we simplify, take here is a minus sign common, minus 1 upon x is common and multiplied with this x. That is, you will get x square into d2y by dx square plus x into dy by dx is equals to minus in bracket a cos log x plus b sin log x. But what is the value of this? The value of this is y. And hence the required differential equation is x square into d2y by dx square plus x into dy by dx plus y. That's equals to 0. Again, I will repeat here. What is there? There are the two arbitrary constants. Therefore, the order of this differential equation is 2. Now, the next problem is a y square is equals to in bracket x plus c bracket q. Now, this equation has one arbitrary constant. Therefore, the order of differential equation must be 1. That is, y square is equals to in bracket c plus x bracket q. Differentiating this with respect to x. What is the derivative of y square? That is a 2y into dy by dx. That is equals to 3 in bracket x plus c bracket square. And what is the derivative of x is 1. Therefore, in this case, that is, you will get x plus c bracket square. That's equals to 2y upon 3 into dy by dx. Now again, take the cube on both sides. Then you will get x plus c bracket raised to 6. And that is equals to 2y upon 3 dy by dx bracket cube. And we can write this in this function. What is that? That is x plus c bracket cube and whole bracket square. And that's equals to, here is a 2y upon 3 into dy by dx whole cube. But what is the value of x plus c bracket cube? It's a y square. And here is a bracket square. The value of x plus c bracket square is a y square. And we have substituted here the y square and it's a bracket square. That is a 2y upon 3, it's a cube, is a 8y cube, and the cube of the 3 is a 27 into dy by dx bracket cube. And if you simplify it, then you will get y square and bracket square, you will get y raised to 4. That is a 27 y raised to 4, that's equals to 8 into y cube in bracket complete dy by dx bracket cube. Now on both sides cancel or divide on the both side by y cube. Then you will get 27y, that's equals to 8 into dy by dx bracket cube. Therefore, 8 into dy by dx bracket cube is minus 27y, that's equals to 0. This is the required differential equation. Now the next problem, that is y is equals to a into e raised to 5x plus b into e raised to minus 5x. Again, this equation has a two arbitrary constant. Therefore, whatever the differential equation, it must have the order 2. Therefore, y is equals to a into e raised to 5x plus b into e raised to minus 5x. Now differentiate this with respect to x. Then you will get dy by dx is equals to a is a constant. What is the derivative of e raised to x? The derivative of e raised to x is e raised to x and into derivative of 5x. That is a 5 plus b. Derivative of e raised to minus 5 is e raised to minus 5x into ddx of minus 5x is minus 5. And therefore, you will get dy by dx is equals to 5a into e raised to 5x minus 5b e raised to minus 5x. Now again differentiate this with respect to x. Therefore, d2y by dx square, that's equals to, again the derivative of e raised to 5x is e raised to 5x into derivative of 5x is 5, and 5 into 5 that will become 25 here. Again differentiate e raised to minus 5x. Again the derivative of e raised to minus 5 is e raised to minus 5x. Again the derivative of it is a composite function. Derivative of minus 5x is a minus 5a. And minus 5 into minus 5, that is a plus 25. And you will get d2y by dx square is equals to 25a into e raised to 5x plus 25b into e raised to minus 5x. Take 25 as common and then you will get d2y by dx square, that's equals to 25 in bracket a into e raised to 5x plus b into e raised to minus 5x. And hence, that is what's the value of this? This is the y. Therefore, d2y by dx square, that's equals to 25y, and therefore d2y by d2y by dx square minus 25y, that's equals to 0. This is the required differential equation. Now the next problem is y minus a bracket square, that's equals to 4 in bracket x minus b. Now again we will differentiate this equation. What's the derivative differentiate? What's the derivative of y minus a bracket square? That's its derivative is 2 in bracket y minus a into dy by dx. What's the derivative of x here? The derivative of x is 1. 1 into 4, that is a 4. Derivative of b is 0. And you will get 2 in bracket y minus a into dy by dx, that's equals to 4. Therefore, y minus a into dy by dx, that's equals to 2. This is first. Now again differentiate this with respect to x. Now apply here the product rule. Keep the y minus a first of all as it is and differentiate this dy by dx. What's its a derivative? Its a derivative is a d2y by dx square plus. Again keep this dy by dx as it is and find out the derivative of y minus a. What's the derivative of y? Derivative of y is a dy by dx and derivative of a is 0. It's a constant. Therefore, dy by dx into dy by dx, that's equals to 0. This is equation number 3. Therefore, what's happening in the equation number 2? That is a y minus a is equals to 2 upon dy by dx. And we will substitute this value of y minus a in the equation number 3. And then you will get that is a 2 upon dy by dx. See this here. The value of y minus a, which is 2 upon dy by dx. We are substituting here and it is written here 2 upon dy by dx. What is that? This second term is as it is. That is the d2y by dx square plus dy by dx into dy by dx. It's become bracket square. How dy by dx into dy by dx, it's become bracket square. That's equals to 0. Again, if we simplify this is the divided term. It will come here and that will be multiplied. If we simplify, then you will get 2 into d2y by dx square plus dy by dx bracket cube, that's equals to 0, which is the required differential equation. Now the next is y is equals to a plus x, a plus a upon x. This is the equation number 1. Again, it has one arbitrary constant, therefore the order of differential equation must be 1. Now differentiate this with respect to x. The derivative of y is a dy by dx. Derivative of a is 0, a upon x. What's the derivative of 1 upon x? Is a minus 1 upon x square. Therefore, what is the value of a? A is equals to minus x square into dy by dx. Substitute the value of this a in the equation number 1. This is the equation number 1. What is the value of a? That's a is equals to minus x square into dy by dx. If you substitute y is equals to, here is the value of a. That is a minus x square into dy by dx. Y is equals to minus x square into dy by dx. This is the value of a plus a upon x. That is a minus x square into dy by dx upon x. And again, if we simplify, and then you will get y is equals to minus x square into dy by dx minus x into dy by dx. And again, if we simplify this and then take the dy by dx as a common, bring this term to the left hand side, and therefore your equation will be x in bracket x square plus x in bracket complete into dy by dx plus y, that's equals to 0. The answer is and question is modified here. This is my correction. Now the next is problem number 8. Y is equals to c1 plus e raised to 2x plus c2 e raised to 5x. This is equation number 1. Now differentiating twice with respect to x because it has two arbitrary constants. Therefore, dy by dx is equals to, what's the derivative of e raised to 2x? Derivative of e raised to 2x is e raised to 2x into derivative of 2x is 2. Therefore, dy by dx is equals to 2c1 e raised to 2x plus 5. Here is again derivative of e raised to 5x is e raised to 5x into derivative of 5x is 5. This is equation number 2. Again differentiate with respect to x. d2y by dx square. By mistake I had written here 3, but here is a 2. Therefore, d2y by dx square, that's equals to 4c1. Again, the derivative of e raised to 2x is a 2 into 2 e raised to 2x. That will become 4. Therefore, 4c1 e raised to 2x. Again, the derivative of e raised to 5x is the 5 e raised to 5x. And 5 and 5, that will become 25 of c2 e raised to 5x. This is equation number 3. These three equations in c1 e raised to 2x and c2 e raised to 5x are the consistent and determinant. Therefore, the determinant of their consistency condition is a 0. Now see this the equation. The first is y. Next is c1 cy. And next is a 1 and 1. Next equation, dy by dx to 5. Next is a d2y by dx square, 4 and 25. Write this y 1 1 dy by dx to 5, d2y by dx square 4 and 25, that's equals to 0. And if you simplify this, that is a y into 2 into 25, that is a 50, 4 into 5, that is a 20. Middle term minus 1. The product of dy by dx into 25, that is a 25 dy by dx, minus 5 into d2y by dx square, plus 1. The product of 4 into dy by dx, minus 2 into d2y by dx square, that's equals to 0. Again, if we simplify, that is a 50 minus 20, that is a 30y, minus 25 dy by dx, minus plus 5 d2y by dx square, plus 4 dy by dx, minus 2 d2y by dx square, that's equals to 0. And then you will get 3 d2y by dx square minus 21 dy by dx, because here is a 4 dy by dx and minus 25 dy by dx. Then you will get minus 21 dy by dx plus this is the 30y, and therefore the differential equation, that is a d2y by dx square minus 7 dy by dx plus 10y, that's equals to 0. This is the required differential equation. Now the next is a problem number 9. Now the next equation is a c1x cube plus c2y square, that's equals to 5. c1x cube plus c2y square, that's equals to 5. This is the one. Differentiate twice with respect to x, then you will get the derivative of x cube is a 3x square into c1. Derivative of y square is a 2y into dy by dx, that is just 2c2y into dy by dx, that's equals to 0. Derivative of constant phi is 0. This is equation number 2. Now again differentiate this with respect to x. The derivative of x square is a 2x. 2 into 3, that will become 6c1x plus 2c2. Now y into dy by dx, now we will differentiate this by using the product rule. That is, first keep y as it is, the derivative of dy by dx is a d2y by dx square, plus again derivative of y is a dy by dx into dy by dx, that will become dy by dx whole square, that's equals to 0. And therefore you will get, that is a 3c1x plus c2, divide on both sides by 2, then you will get, that is a 3c1x plus c2 in bracket y into d2y by dx square plus dy by dx bracket square is equals to 0. And these are three equations in A and B are the consistent. Therefore, we'll take this, that is the first is not A and B, and that is a C1 and C2. Therefore, we'll take here the first is x cube y square and 5. Here is a x cube y square and 5. Now the next equation, that is equation number 2. Then you will get, that is a 3x square 2y into dy by dx and the 0. That is a 3x square 2y into dy by dx, that's equals to 0. And the last is, that is a equation number 3. That is a 3x in bracket y into d2y by dx square plus dy by dx bracket square, and the last will be 0. Now solve this determinant. Then you will get x cube, the product of these two will be 0. What about the y square? Again the product of these two will be 0. And last term will be present there, that is a 5 in bracket the product of 3x square into in bracket y into d2y by dx square plus dy by dx bracket square. And next is a minus 3x into 2y dy by dx. That is a minus 6xy into dy by dx, that's equals to 0. Therefore, these two terms will be 0. And overall, you will get that is a 3x square y into d2y by dx square plus 3x square dy by dx bracket square minus 6xy into dy by dx, that's equals to 0. Therefore, xy into d2y by dx square plus x into dy by dx bracket square minus 2y into dy by dx, that's equals to 0, which is the required differential equation. Now the 10th problem, y is equals to e raised to minus 2x in bracket a cos x plus b sin x. Now again, if we simplify this, then e raised to minus 2x, 1 upon e raised to 2x, and again if we simplify, then you will get y into e raised to 2x, that's equals to a cos x plus b sin x. Now differentiate this with respect to x. Apply here the product rule. Y into derivative of e raised to 2x is e raised to 2x, derivative of 2x is 2. plus e raised to 2x and derivative of y is a dy by dx. Now a cos x plus b sin x. What is the derivative of cos x? Is a minus sin x. Plus what is the derivative of sin x? Is a b cos x. And here is a, that is a take e raised to 2x as a common. That is a 2y plus dy by dx bracket complete e raised to 2x. That's equals to minus a sin x plus b cos x. Again differentiate this with respect to x. Now here we will apply the product rule for these two terms. Which are the two terms? That is a 2y plus dy by dx into e raised to 2x. But first differentiate this 2y plus dy by dx. And what's its derivative? That is the derivative of y is a dy by dx. That is a 2y into dy by dx. The derivative of dy by dx is a due to y by dx square. Keep this e raised to 2x as it is. And the next is a 2y plus dy by dx. Keep this as it is. Derivative of e raised to 2x is e raised to 2x into derivative of 2x is 2. Now again differentiate this. What is the derivative of sin x? Is a cos x, and derivative of cos x is a minus sin x. And take here that is a minus sign as a common. Then you will get the value of a cos x minus b, a cos x plus b sin x, a cos x minus b sin x. The value is y into e raised to 2x. This is the value a cos x plus b sin x. त्याची value किती आली? तर y into e raised to 2x. Now here is a y into e raised to 2x, y into e raised to 2x cancel on both sides, e raised to 2x, e raised to 2x, and then you will get what's the equation? That is a d2y by dx square plus here is a 2 into dy by dx, I hit a 2 into dy by dx, in either 2 into 2 into dy by dx, this 2 into 2 dy by dx plus 2 into dy by dx, that will become 4 dy by dx. Here is a 2 into 2y, and that will become 4y, and here is a minus y. Bring this to the left hand side, and that will become 5y. That's equals to 0. And hence the required differential equation is a d2y by dx square plus 4 dy by dx plus 5y. That's equals to 0. Now the next, form the differential equation of the family of the lines having the intercept a and b on the coordinate axis respectively. Now we want to form the differential equation of the family of lines having the a and b intercept on the coordinate axis. The equation of the line having the x intercept is a and the y intercept is b is given by in this fashion. That is x upon a plus y upon b, that's equals to 1. A and b are the arbitrary constant. Now differentiate this. The derivative of x is 1. 1 into 1 upon a, that is 1 upon a, plus 1 upon b. Derivative of y is a dy by dx. Derivative of 1 is 0. And therefore you will get the 1 upon b into dy by dx, that's equals to minus 1 upon a. Therefore dy by dx is equals to minus b upon a. This is equation number 2. Now again differentiate this with respect to x. Then you will get the d2y by dx square, that's equals to, this is the constant and its a derivative is a 0. Therefore d2y by dx square, that's equals to 0, which is the required differential equation. d2y by dx square, that's equals to 0, which is the required differential equation. Problem number 3. Find the differential equation of all parabola having length of a lattice rectum, that is a 4a, and axis is parallel to the x-axis, and these are the parabola. And their axis is parallel to x-axis, and the vertex of this parabola is hk. Now see this here. Since the axis of parabola is parallel to x-axis, and 4a is it's a lattice rectum, the equation of such a parabola is a y minus k bracket square is equals to 4a in bracket x minus h. This. Now a, h and k are the arbitrary constant. Now differentiating equation 1 twice with respect to x. The first derivative of y minus k bracket square, it's a 2 in bracket y minus k into derivative of y, which is dy by dx. That's equals to derivative of x is 0. Then derivative of x is 1. And derivative of h is 0. 1 into 4a, that is equals to 4a. That is a 2 in bracket y minus k into dy by dx, that is equals to 4a. Now the next is a y minus k into dy by dx, that's equals to 2a. This is the value of y minus k into dy by dx, that's equals to 2a. And the y minus k d2, and again now differentiate this with respect to x. That is a y minus k as it is. Derivative of dy by dx is a d2y by dx square plus derivative of y is a dy by dx. Derivative of k is 0. Now here is a dy by dx and again dy by dx. That will become dy by dx bracket square. इथे product rule आपण apply केलेला आहे. पहिल्यांदा keep y minus k as it is. Derivative of dy by dx is a d2y by dx square plus हा dy by dx जसाच तसा आणि या y चा डेरिव्हेटिव्ह dy by dx into this dy by dx that will become dy by dx bracket square that's equals to 0. Now from the equation number 2 we get that is a y minus k is equals to 2a upon dy by dx. 2a upon dy by dx from the equation number 2. See this here. Dy by dx is equals to 2a upon y minus k. Substituting this value of the y minus k in the equation number 3. Substitute here the value of y minus k here. That is, you will get 2a upon dy by dx into d2y by dx square plus dy by dx bracket square that's equals to 0. And again, after simplifying, that is a 2a into dy by dx. This dy by dx will multiply to this dy by dx bracket square. That will become dy by dx bracket cube upon dy by dx, and overall that will become a 0. That's equals to 0. Which is the required differential equation, that is a 2a in bracket d2y by dx square plus dy by dx brackets cube that's equals to 0. Now the problem number 4. Find the differential equation of ellipse whose major axis is a twice its a minor axis. Now here the minor axis is a small a and the major axis is 2a. Therefore the equation of the ellipse is x square upon a square plus y square upon b square that's equals to 1. But here is a that is a x square upon that is a 2a bracket square that will become 4a square plus y square upon a square that's equals to 1. If we simplify this, then you will get x square plus 4y square that's equals to a square. And therefore the differentiating this with respect to x. The derivative of x square is a 2x and derivative of y 4y square is a 2y into dy by dx that's equals to 0. Derivative of y square is a 2y into dy by dx, and overall it will become 8y into dy by dx. And the derivative of constant a square is 0. And again the simplifying, you will get x plus 4y into dy by dx that's equals to 0, which is the required differential equation. Now the problem number 5. Form the differential equation of the family of lines parallel to the lines 2x plus 3y plus 4 equals to 0. The equation of the line parallel to the line 2x plus 3y plus 4 equals to 0 is 2x plus 3y plus c equals to 0, where c is arbitrary constant. Now differentiate this with respect to x. That is the derivative of 2x is a 2, derivative of 3y. That is a 3 into dy by dx, the derivative of c is a 0. Therefore 3 into dy by dx plus 2 is equals to 0. This is the required differential equation. Now the problem number 6. Find the differential equation of all circles having the radius 9 and the center at a hk. Now we know the center of this circle, which is hk, and the radius is 9. By using the center radius form, then you will have the equation of the circle is x minus h bracket square plus y minus k bracket square that's equals to 81. Now differentiate this with respect to x. That is a 2 in bracket x minus h plus 2 in bracket y minus k into dy by dx that's equals to 0. Therefore the x minus h plus y minus k into dy by dx that's equals to 0. Differentiate this again with respect to x. The derivative of x minus h, that is the derivative of x is 1, derivative of h is 0. Y minus k into dy by dx that's equals to 0. Apply here the product rule. Now y minus k into derivative of dy by dx is the d2y by dx square plus dy by dx as it is, and derivative of y minus k. Derivative of y is a dy by dx into dy by dx, that will become dy by dx bracket square that's equals to 0. Therefore what is the value of this y minus k? Now here is a 1 plus dy by dx bracket square. Now bring this term to the left hand side. That will become minus in bracket y minus k into dy by d2y by dx square. Therefore the y minus k, the value of, if you simplify this, then you will get the value of y minus k that's equals to minus in 1 plus dy by dx, this 1 plus dy by dx bracket square upon d2y by dx square. This is the value of y minus k. And overall that is from the equation number 2. What is the value of y minus k? The value of y minus k is a minus in bracket minus 1 plus dy by dx bracket square upon d2y by dx square. That is a x minus h is equals to dy by dx in bracket 1 plus d2y by dx bracket square upon d2y by dx square. This is the from 2, and therefore this is the value of y minus a. Again the from the 2 x minus h, that is the dy by dx in bracket 1 plus dy by dx bracket square upon d2y by dx square. Substituting the value of x minus h and y minus k in the equation number 1. What are the value of x minus? This is x minus h, and again here is y minus k in the equation number 1. Then you will get, this is the differential equation, that is the dy by dx bracket square in bracket 1 plus dy by dx bracket square whole square upon d2y by dx square bracket square plus in bracket 1 plus dy by dx bracket square whole bracket square upon d2y by dx square and whole bracket square, that's equals to 81. And if you simplify this, then you will get, this is the common base, then you will get 81 into d2y by dx square whole square is equals to d2y by dy by dx bracket square in bracket 1 plus dy by dx bracket square and whole square, and plus in square bracket 1 plus dy by dx bracket square and whole square. This is the big equation, and therefore you will get that is the 81 in bracket d2y by dx square whole bracket square, that is equals to in square bracket 1 plus dy by dx bracket square and whole square into 1 plus dy by dx bracket square, and there is the square and the single power, that will become cubical term, that is 81 into d2y by dx square whole square, that's equals to 1 plus dy by dx bracket square bracket is to 3. This is the required differential equation. Now the next problem, that is form the differential equation of all the parabolas whose axis is the x-axis. Now see this here, the vertex of this parabola is a b comma 0. The equation of the parabolas whose axis is x-axis is y square is equals to 4a in bracket x minus 0, because its a vertex is a b0, therefore x minus a. A and b are the arbitrary constant. Now differentiate this with respect to x. Derivative of y square is a 2y into dy by dx, and here is a derivative of x is 1. That is equal, you will get the 4a. That is a 2y into dy by dx, that is equals to 4a. Therefore 2a is equals to y into dy by dx. Now again differentiate this with respect to x. Derivative of 2a is a 0, and the derivative of y into dy by dx, this is a y. Derivative of dy by dx is a d2y by dx square plus again the derivative of y is a dy by dx into dy by dx, that will become dy by dx bracket square. Therefore the required differential equation is a dy by dx bracket square plus y into d2y by dx square, that's equals to 0. This is the required differential equation, and in this way we have completed the exercise 6.1 and 6.2. Now we'll see in the next video, and then goodbye.